Rio de Janeiro, 1952. A physics professor walks into his university lecture hall and writes a simple question on the board. What makes an angle in a crystal? 80 students stare back. Perfect silence. He tries again, rephrasing. Nothing. These are advanced physics students who just aced their quantum mechanics exam last week. They should know this cold. What Feynman discovered in that classroom would expose a crisis in education that still devastates millions of students today. This comes from Richard Feynman's documented teaching experience in Brazil, recorded in his memoir, Surely You're Joking, Mr. Feynman, and verified through archives at the Centro Brasileiro de Pesquisas Físicas, the physicist who would later win the Nobel Prize and revolutionize our understanding of quantum mechanics, spent nearly 2 years teaching in South America. He expected brilliant minds eager to unlock the mysteries of physics. He found something else entirely. Feynman arrived in Rio in 1951 as a visiting professor, hired to strengthen Brazil's emerging physics program. The university boasted modern facilities, ambitious students, and a curriculum imported directly from America's top institutions. On paper, everything looked promising. The students attended every lecture, took meticulous notes, and spent hours studying in the library. Their exam scores were immaculate. Perfect recitation of Maxwell's equations, flawless reproduction of thermodynamic principles. These weren't struggling students, they were academic superstars. But something felt wrong. During his third week, Feynman demonstrated polarized light using 2 calcite crystals. He held them up, rotated one, and watched the light intensity change. Basic optics, first-year material. He asked the class to explain what they were seeing. Blank stares. But you just had a whole semester on electromagnetic waves, Feynman said, genuinely confused. One brave student raised his hand. Professor, we studied electromagnetic waves. We did not study calcite crystals. That's when Feynman began to suspect he wasn't teaching physics. He was witnessing something far more disturbing. A perfect system for preventing learning while maintaining the illusion of education. He designed an experiment. In the next class, he asked students to define Brewster's angle. Hands shot up. They recited the textbook definition word for word, including the mathematical formula. Impressive. Then Feynman asked, "Look at the bay outside this window. Can you see how the light reflects off the water at different angles? Is Brewster's angle happening right now?" The room went silent. They had memorized Brewster's angle so thoroughly they could write essays about it. But they couldn't recognize it happening 30 feet away. This pattern repeated in every topic. Students could recite Newton's laws, but couldn't explain why a bicycle stays upright. They knew the formula for kinetic energy, but looked confused when asked about a ball rolling down a ramp. They had learned physics the way someone might memorize a foreign phrase book without understanding the language. Feynman tried different approaches. He simplified questions. He used real objects instead of abstract symbols. He asked them to predict simple outcomes before calculating anything. Nothing worked. The more he probed, the more obvious it became. His students had spent years studying physics without ever thinking about physics. But here's where the story gets darker. These students weren't lazy. They weren't stupid. They studied harder than most American students Feynman had taught. They spent entire nights memorizing textbooks. Their dedication was absolute. That was precisely the problem. Feynman started investigating the Brazilian education system beyond his classroom. He attended other lectures, reviewed exam papers, talked with students from different universities. What he discovered was a machinery of knowledge destruction operating at industrial scale. Students learned that professors ask questions in predictable patterns, memorize the exact phrasing from textbooks, reproduce it verbatim on exams, and you succeeded. Every incentive pointed toward memorization. Every assessment rewarded recitation. The entire system had evolved to measure the appearance of learning while actively preventing actual understanding. One evening, Feynman met with a group of engineering students preparing for their final exams. He watched them quiz each other. "What is the definition of triboluminescence?" one asked. Another student recited, "Triboluminescence is the light emitted when crystals are crushed." Perfect answer. Textbook definition. Feynman interrupted. "Have any of you ever seen this happen?" Confused looks. "Seen what?" triboluminescence, light from crushing crystals. You can do it with sugar cubes in the dark. None of them had. They were memorizing the definition of a phenomenon they'd never witnessed, couldn't imagine, and wouldn't recognize if it happened in front of them. Feynman realized these students were trapped in what he later called cargo cult science. They had all the superficial forms of learning without any of the substance. They possessed the vocabulary of physics, but none of its power. They could pass any test, yet solve no real problems. You felt this frustration when you've crammed for an exam, aced it, then couldn't remember anything a week later. That hollow feeling when you realize you memorized your way through material without understanding any of it. Feynman's students experienced this every single day, but the system told them they were succeeding. This wasn't just about Brazilian education in 1952. This was about the fundamental difference between two types of knowledge: knowledge that decorates the mind versus knowledge that transforms it. The Brazilian students had accumulated facts like decorative objects. Each definition, each formula, each principle sat in their minds as a separate, isolated piece. When asked about Brewster's angle, they retrieved the Brewster's angle fact. When asked about reflection, they retrieved the reflection fact. But these facts never connected. They never formed a web of understanding that could respond to novel situations. Real physicists think differently. They build models, mental simulations of how the world works. When Feynman looked at light reflecting off water, his mind automatically ran physics, not because he memorized light reflects at Brewster's angle off water, but because he understood electromagnetic waves, understood how they interact with matter, and could predict outcomes from fundamental principles. The students had no models, they had scripts. And scripts only work when reality follows the exact scenarios you've memorized. Feynman confronted this head-on in his final lecture. He stood before the assembled faculty and students and delivered what accounts describe as a devastating critique. He told them their system produced students who pass examinations and pass them pretty well, but in which we do not know anything except what we have memorized. The room erupted in defensive arguments. Professors insisted their methods were sound. Look at the test scores. Students protested that they worked incredibly hard. How dare he suggest they knew nothing? But Feynman wasn't attacking their effort. He was exposing their tragedy. These brilliant minds had invested years in a system designed to prevent them from becoming scientists while convincing them they were succeeding. He put it plainly in a quote that still reverberates through education debates. After a lot of investigation, I finally figured out that the students had memorized everything, but they didn't know what anything meant. Let that sink in. They didn't know what anything meant. Every formula was a magic spell. Every definition was empty words. They could reproduce the entire textbook without comprehending a single concept. This reveals something crucial about how knowledge actually works. Real understanding isn't about storage. It's about transformation. When you truly learn physics, you don't just acquire new facts. You acquire new ways of seeing. Light stops being just light and becomes electromagnetic waves propagating through space. Motion, it stops being just movement and becomes the interplay of forces, energy, and momentum. Feynman's students never experienced this transformation. They treated education as data entry, pour information into brain, retrieve information on demand. But human minds don't work like hard drives. We understand through connection, through application, through watching ideas collide and transform. The same principle applies today when you watch tutorial videos at 2x speed, highlight textbooks in multiple colors, or create elaborate notes you never review. You're building the appearance of learning while avoiding the actual work, grappling with ideas until they yield their meaning. Modern education has perfected the Brazilian system's flaws. We have students who watch lecture videos and feel like they understand, then freeze on the exam. We have professionals who complete certifications without gaining competence. We have entire industries built on courses that provide certificates rather than capabilities. The markers of fake learning are everywhere. Someone can explain a concept to you, but can't answer basic what-if questions. Someone's resume lists impressive credentials, but they can't solve simple problems in their field. Someone has read dozens of books on a topic, but their thinking hasn't changed at all. You recognize this in yourself when you realize you've been studying something for months, but still can't use it. When you need to look up the basics every time. When you can recognize the right answer on a multiple choice test, but couldn't generate it from scratch. Feynman identified the mechanism behind this failure. The Brazilian students weren't building knowledge from the ground up. They were memorizing the finished product. They learned conclusions without premises, results without derivations, formulas without the logic that produced them. It's like trying to understand a building by memorizing a photograph. You might accurately describe what it looks like, but you won't understand why it stands up, how the weight distributes, or what happens if you remove a support beam. Real learning starts with simple questions that demand real thinking. Not define electromagnetic induction, but why does a generator need to spin? Not recite Newton's second law, but predict what happens when I push this cart on a frictionless track. Feynman spent his last months in Brazil trying to demonstrate this approach. He brought broken radios into class and asked students to make them work. No formulas allowed, just think. He took them outside and made them explain ordinary phenomena using physics principles. He banned memorized definitions and demanded explanations in their own words. Some students resisted. This felt harder than memorizing, and it was. Thinking always is. But a few started to break through. They had moments Feynman called the pleasure of finding things out. That electric feeling when understanding clicks and the world suddenly makes sense. Those students learned what it means to know something, not to recite it, not to recognize it, but to command it. To take an idea and turn it over in your mind, test its boundaries, apply it to new situations, and make it yours. Here's what Feynman understood that the Brazilian system missed. Learning is transformation, not accumulation. You don't truly know something until it changes how you see the world, until you can't look at a rainbow without thinking about refraction, until you can't watch a ball drop without seeing acceleration, until the knowledge becomes automatic, instinctive, part of how your mind operates. This is why cramming fails. Why highlighting fails. Why passive note-taking fails. You're trying to accumulate when you need to transform. You're decorating your mind when you need to rewire it. The students who break through are the ones who stop asking, "What should I memorize?" and start asking, "What would happen if..." They're the ones who close the textbook and try to rederive concepts from scratch, who attempt problems before looking at solutions, who teach others and discover their own gaps. They're willing to feel stupid temporarily because they understand that confusion is the raw material of learning. That struggle is where transformation happens. That the discomfort of not knowing is the price of admission to truly understanding. Feynman left Brazil with a reputation as a troublemaker who didn't appreciate the students' hard work, but decades later, his critique proved prophetic. The system he exposed in Rio exists everywhere, in universities that optimize for rankings instead of learning, in professional training that produces certificates instead of competence, in online courses that sell the fantasy of easy expertise. We've built elaborate mechanisms for avoiding the hard work of actual learning, while maintaining perfect appearances. We've created a world where you can have all the credentials and none of the capability, where you can study for years and understand nothing. But we've also proven Feynman right about the solution. The students who break through share one trait. They refuse to pretend. They don't hide behind memorized definitions. They test themselves ruthlessly. They admit what they don't understand and stay in that discomfort until clarity emerges. They ask why until they reach bedrock. They explain concepts to themselves out loud. They seek problems they can't solve and refuse to look at answers until they've genuinely struggled. They know the difference between "I've seen this before" and "I understand this deeply." That difference, between recognition and understanding, between memory and mastery, is what Feynman illuminated in that Brazilian classroom 70 years ago. The crisis he exposed never ended. It just evolved better disguises, which means the question he left hanging in Rio still waits for each of us. Are you learning, or are you just memorizing? Do you understand, or do you just recognize? Can you use what you know, or only repeat it? The next time you feel certain you've learned something, try Feynman's test. Close the resources. Explain it to an empty room. Apply it to a situation you've never seen before. See what happens when you're forced to think instead of recall. That's where real knowledge begins, in the uncomfortable gap between what you thought you knew and what you can actually do. Feynman showed his Brazilian students that gap. Some chose to bridge it. Most chose to ignore it. The choice remains yours.